Assalamu alaikum. Our lecture for today is chi-square test. The chi-square distribution is a theoretical or mathematical distribution. And since the Greek letter chi was used to define this distribution and the elements it used are all squared, it is called chi-square test. It is non-parametric statistical test. It differs from the t-test in that here we don't make assumptions about the parameters of the population from which the data or the sample was drawn. And it is the most frequently employed statistical test for analysis of count or frequency data. And this is another difference from t-test, in which we were dealing with means of samples or groups. There are two types of chi-square tests. The goodness of fit test, which is used when we want to test a hypothesis for one categorical variable. The second is the chi-square test for independence of two variables, which is used when we want to test a hypothesis for two categorical variables. Categorical variable means any variable or factor which has two or more levels or categories. For example, education, as we can categorize the education into primary, secondary, college, higher education, or for example, gender, which has two levels, male and female, or two categories. Also, another example is the color of the hair, color of the eye, and so on. Here, we will go through the first type of chi-square test quickly, as the aim here is for you to have a general understanding of the concept. However, we go into much more details with type 2, as the aim here is for you not only to understand the concept, but also to be able to solve problems in relation to the topic. First, the chi-square goodness of fit test is applied when we have one categorical variable from a single population. It is used to determine whether sample data are consistent with a hypothesized distribution. But there are certain conditions that should be met when we apply this test. First, the sampling method is simple random sampling, and the variable under study is categorical. And the third thing is that the expected value of the number of sample observations in each level of the variable is at least 5. The first step in conducting the chi-square goodness of fit test is to state the hypothesis, both the null and alternative hypothesis. And as we said before, these should be stated in such a way that if one is true, the other must be false, and vice versa. So for a chi-square goodness of fit test, hypotheses take the following form. The null hypothesis, the data are consistent with a specified distribution, while the alternative hypothesis, the data are not consistent with a specified distribution. Typically, the null hypothesis specifies the proportion of observations at each level of categorical variable. The alternative hypothesis is that at least one of the specified proportion is not true. The second step is to formulate an analysis plan to describe how to use sample data to accept or reject the null hypothesis. And here the following elements should be specified. First, you should specify the significance level. And researchers often choose 0.05 as level of significance, but as we said before, any value between 0 and 1 can be used. Secondly, you should also specify the test method, and here chi-square goodness of fit test is used to determine whether observed sample frequencies differ significantly from expected frequencies specified in the null hypothesis. The next step is the analysis of the sample data. So we are going to use the sample data to find the degrees of freedom, expected frequency counts, test statistic, and the p-value associated with the test statistic. For the degrees of freedom of the goodness of fit test is equal to the number of levels of the categorical variable minus 1, or df equal k minus 1. So if we have a categorical variable of 4 levels, for example, df will be equal 4 minus 1 equal 3. Then the expected frequency counts for each level of the categorical variable should be estimated, which equals the sample size times the hypothesized proportion from the null hypothesis. So E expected equal NP. E, as we said, it is the expected frequency count for any level of the categorical variable. N is the total sample size, and P is the hypothesized proportion of the observations in that level. Test statistic is a chi-square random variable defined by the following equation. Chi-square equals the summation of observed minus expected squared over expected. O is the observed frequency count for the level or any level of the categorical variable. E is the expected frequency count for that level of the categorical variable. The last step is to interpret the results. If the sample findings are unlikely given the null hypothesis, the researcher rejects the null hypothesis. Typically, this involves comparing the p-value to the significance level and rejecting the null hypothesis when the p-value is less than the significance level. This slide shows an example of goodness of fit test. As you can see, the following table shows data samples sorted into 4 categories with an assumed probability distribution. So the first column shows the factor or the variable levels. Here they are 4 variables. For example, educational status, social class, hair color, marital status. Then the second column showing the assumed probability or proportion distribution. The third column shows the observed frequencies. So first of all, you are going to estimate the total sample size by adding the observed frequencies. And here, N or sample size equals 100. Then to estimate the expected frequency, you are going to multiply each observed frequency by the proportion or probability at that level. So, for example, to estimate the expected frequency for the observed value 10, it will be equal to 100 multiplied by 0.03. For the value 45, the expected is 100 multiplied by 0.09. Then the calculated chi-square value will be estimated by using the chi-square equation. And after that, you are going to compare it with tabulated value from the chi-square distribution table to interpret your results. The second type is chi-square test for independence of 2 variables. Chi-square distribution can be used for testing hypotheses where the data available for analysis are in the form of frequencies. Chi-square statistic is most appropriate for use with categorical variables, such as marital status. This variable can be categorized into married, single, widowed, and divorced. By using this test, we might want to know if in the population from which the sample was drawn, there is a relationship between 2 categorical variables. The quantitative data used in computation of the test statistic are the frequencies associated with each category of the variables under study. And as we knew before, there are two sets of frequencies with which we are concerned, the observed and the expected frequencies. The observed frequencies are the number of subjects or objects in our sample that fall into the various categories of the variable of interest. The expected frequencies are the number of subjects or objects in our sample that we would expect to observe if some null hypothesis about the variable is true. This slide shows a data sample sorted into a 2x2 contingency table based on two factors or two variables, each of which has two levels or two categories. So as you can see from this table, there are two variables, each has two levels. Variable 1 could be the disease status, which has two levels, present and absent. The other variable 2 could be the gender, which has two levels or two categories, male and female, or residence, which can be classified into urban and rural. One of these factors could have three levels, and now we can call the table a 3x2 contingency table. Or variable 1 might have three levels, and variable 2 may have three levels also, and then it will be called the 3x3 contingency table. So for this 2x2 contingency table, or we can call it also 4-cell table because it has 4 cells, A, B, C, and D. We are going to find the column totals, C, and the row totals, R, and the grand total or the sample size, N. Then we are going to find the expected number, E, of observations for each cell based on the assumption that the two factors are independent, by using the formula of the expected, which is the expected equals row total multiplied by column totals divided by N, or the grand total. So for example, if we want to find the expected value of the observed frequency 10, the expected equals row total 30 multiplied by column total 20 divided by the grand total 50. And also for the observed value 15 for cell C, the expected equals row total 20 multiplied by column total 35 divided by grand total 50. Then, after finding the expected value for each of the 4 cells, A, B, C, and D, we are going to find the chi-square value. According to the equation, chi-square equals the summation of observed minus expected squared over the expected. And then you are going to find the number of degrees of freedom of the chi-square test statistic. The degrees of freedom here equals number of rows minus 1 multiplied by number of columns minus 1. So for this example, or for this table, the degrees of freedom equals 1. After that, we are going to find the tabulated chi-square value and compare it with our calculated chi-square value to interpret the results. In this slide, you can see the equation of the expected, which equals the row total multiplied by column total divided by grand total N. And this slide also shows the equation of chi-square test statistics, which equals summation of observed minus expected squared over the expected. Also, the equation or the formula of degrees of freedom, which equals number of rows minus 1 multiplied by number of columns minus 1. An example on chi-square test. Distribution by socio-economic class of patients admitted to self-poisoning, sample A, and gastroenterological, sample B units. Here we are going to see if the distribution according to social class differ among the two samples. The data of this example are shown in this table. So you can see there are two variables. The first variable of samples, which has two levels according to the unit of admission, to the self-poisoning unit group A and gastroenterological unit group B. The other variable is the socioeconomic class, which has 5 levels. So this table has 10 cells. They can be, if you want to number these cells, they are A, B, C, D, E, F, G, H, I, and J. Also, you can see the row totals and the column totals with the grand total. So first you are going to put the null hypothesis and the alternative hypothesis. The null hypothesis states that there is no difference in the distribution according to social classes among the two samples, while the alternative hypothesis states that there is a real difference in the distribution according to social classes among the two samples. Then calculate the expected value for each cell. According to the equation, the expected value equals row total multiplied by column total divided by grand total of that value. For example, if we want to calculate the expected value 17 in cell A, it equals to 22 multiplied by 155 over 289 equals 11.8, and so on with each cell. To calculate the chi-square value, we will construct a table as follows. This table includes all the estimated values for all the 10 cells at all levels of the two categorical variables, which are the expected number, the observed minus expected, and then observed minus expected squared over the expected. We may notice the following here. First, the sum of the expected number is always equal to the sum of the observed. So here you can notice that the sum of the expected numbers of sample A, which is 155, is equal to that of the observed numbers in the previous table, which is also 155. The second thing is that the sum of the differences between the observed and the expected numbers always come to 0. The third thing is that each difference for sample A is matched by the same figure but with opposite sign for sample B. For example, 5.20 for sample A is matched by minus 5.20 for sample B. Then the chi-square value will be calculated by adding all the estimates of observed minus expected squared over the expected together. The chi-square value is calculated by applying the equation of the chi-square test, and it equals 7.147. Also calculate the degrees of freedom according to the equation number of columns minus 1 multiplied by number of rows minus 1, which is equal to 4. And by using the chi-square distribution table at 4 degrees of freedom and at 0.05 level of significance, the chi-square tabulated value is equal to 9.488. So the result is that the calculated chi-square value is less than tabulated, and we find the p-value more than 0.05 level of significance. So the null hypothesis is not rejected, and our interpretation is that there is no significant difference in the distribution among the two samples according to social classes. An important thing that you should know about this test is that the chi-square test is valid only if at least 80% of the expected frequencies exceed 5 and all the expected frequencies exceed 1. There is a shortcut chi-square formula for 2x2 tables only, as shown in this table. So according to this shortcut formula, the chi-square value equals n multiplied by AD minus BC squared divided by the multiplication of A plus C, B plus D, A plus B, and C plus D. Thank you.